All right, good morning. It's time to go over the review questions for the test concerning mixtures, elements, compounds, and mixtures. All right, and again, you should have already done this and already submitted it to me so that so I've already given you a grade for it. Now it's time to go over the answers so that you have the right answers so you know you're doing this correctly. Remember on this test, yes, you can utilize, the plan is currently that you can still utilize your notes, but the questions aren't going to be like verbatim. They aren't going to be exactly what's on the review. So you really have to use your head and you have to think about things in order to answer the questions. So the very first one, explain the difference between an element and a compound using pictures and words. So a picture explanation, one way in which you could do this is you could make two different elements. Make one a circle that's open and one that's a circle that's closed. So each one of those would be a representation of a different element. Notice they aren't bonded together, not linked together. Then we could take those and we could put them together and we could make it look something like this. So that really what I've got is I got one of these elements and then I got two of those elements and they're chemically combined, they're connected together. Right. So it's just one way of looking at this is like a picture to be able to tell the difference between elements and compounds. If we do a word explanation, what's an element? It's one type of atom. So all of the atoms for an element are all exactly the same for that element. Like gold, all of them are the same and all atoms of gold are the same. Then we got compounds. Compounds are two or more atoms or two or more elements that are chemically combined. So they are chemically combined together. All right? They're not mixed together, they're chemically combined together. All right, question number 2, describe the characteristics of the following two categories of mixtures. You got a heterogeneous mixture. A heterogeneous mixture means it's different throughout. All right, from the top to the bottom, like the idea we used in class, muddy water. The top's going to be fairly clear with very little mud. Down at the bottom, there's going to be a lot of mud and very little water. So it's different from top to bottom. It does show the Tyndall effect. Right? The other one that also falls under this category is a colloid, which happens to be cloudy. They also show the Tyndall effect. And remember, the Tyndall effect was the idea that you shine a beam of light through it, a laser, you're going to be able to see that beam of light going through it. The second half to this is a homogeneous mixture. Homogeneous is the same throughout. So this would be like a bottle of pop, where the first drink of pop and the last drink of pop all taste exactly the same. And these, there is no Tyndall effect. You shine a beam of light through it, you're not going to be able to see that beam. Right? You're just going to see a dot somewhere on the other side. Right? Number 3, list the first 18 elements from the periodic table with their symbol and name. I am not going to go over those specifically on here. What I want you to do, hopefully you will have looked at your periodic table and you have those all listed out and you know their names and their symbols. Right? And I hope that you got a periodic table downloaded from somewhere. Again, just use a Google search and you'll be able to find a periodic table that you can save on your computer because you're going to have to reference it or print it off so that you can always look at it, because you will be utilizing the periodic table from this point on all the way until the end of this course. Right? It's something we regularly look at. Question number 4. If you take 23.0 grams of sodium and completely, keyword completely, combine that with 17.0 grams of chlorine, how much of the compound sodium chloride would be formed? So you're really just going to take 23 plus the 17, add those two together, you get 40.0 grams of sodium chloride is what would be formed, because all of this combines together in this case. All right, now we're going to classify the following, number 5, as homogeneous or heterogeneous. Black coffee, that's the same drink from the top to the bottom, so it is homogeneous. It's the same. Letter B, Gatorade. A glass bottle of Gatorade is the same drink top to bottom, so that's homogeneous from top to bottom. Whipped cream, oh, it's cloudy, which I'm going to go back for a second and go, we have those 3 types. We got suspension, colloid, solution. Those are the 3 mixtures that fall underneath this. Suspension, remember, settles, that's a heterogeneous. Colloids are cloudy, that's a heterogeneous. And the third type, solutions, are clear, and that's a homogeneous. So when we look at whipped cream, which one does that look like? Probably a colloid because it's cloudy, so it is heterogeneous. Letter B, brass, which is a blend of copper and zinc. That's the same throughout, okay? So that's homogeneous. And the last one in this, salt water, that one again is the same throughout and it's clear, so therefore that one's also homogeneous. All right, number 6, describe the following types of mixtures, include the size of the particles and a general characteristic. Colloids, remember they have a medium sized particle and they are cloudy. So their particles are medium size and they're cloudy. They do not settle. Letter B, suspensions. They have large particles compared to the other two. And because the particles are so large, they do settle down to the bottom when the liquid is not moving around. The letter C, solutions. Solutions have really small particles. And these guys tend to be clear because the particles are so small. 7, identify the following as a colloid, suspension, or solution. Remember, keep using those ideas. Kool-Aid. Kool-Aid is clear. It might have a color, but it is clear. So it is a solution. Muddy water. That one settles when you leave it sitting around, so that's a suspension. Pancake syrup. That one's clear. Might be dark, but it's still clear. You can see through it, so that's a solution, and you don't have to mix it up. Last one, white milk. That one's cloudy, so that's a colloid. Number 8, identify the following as an element, a compound, or a mixture. Sodium, that's on your periodic table. Its symbol is Na, capital N, lowercase a. That's an element. Next one, carbon dioxide. I gave you the formula, CO2. That C, that's carbon. O is oxygen, so those are bonded together, so that's a compound. Letter C, distilled water. That's H2O. That's hydrogen combined with oxygen. That's also a compound because it's two elements combined together. Letter D, Pepsi. Pepsi is a mixture. It's a mixture of water, sugar, food coloring, and flavoring. That's all it is. Really just Kool-Aid. But the only thing that makes it Pepsi is because it's got some carbon dioxide in it to give it bubbles. So it's a mixture. Letter E, Kool-Aid. Kool-Aid again, just like Pepsi without the carbon dioxide. That's a mixture also. Last one, silicon. Silicon is an element that's on the periodic table. It's element Si. All right, number 9, describe the difference between a physical and a chemical change. Physical does not change the properties. Everything is still the same. All right, I tear a piece of paper in half. It's still 2 pieces of paper. All right, it's still paper. I didn't change it. Versus chemical does change its properties. If I burn a piece of paper, can I get the piece of paper back easily? Nope. Once I burned it, it's hard to get it back. It's something totally new and different. That is a chemical change. So that would be the one thing that I would look at if I were you on the test, is when you're trying to tell these, decide, is it still the same stuff or did it become something new so I can't get the original stuff back? Number 10, identify the following as physical or chemical change. Boiling water. Boiling water turns into water vapor. Oh, keyword still water vapor, so that's a physical change. Letter B, burning a piece of paper. We just talked about that. That is a chemical change. C, freezing rain into snow. It's still water, so that's physical change. Number 11, label the following as physical or chemical property. Rusting a metal, when it reacts with oxygen, it's reacting. That means a chemical property. Letter B, it feels soft. That's a physical property. Letter C, gold is yellow. It's something that you can identify with your senses, so that's a physical property. And letter D, something that burns. Once it burns, it's something new. That's actually a chemical property. Number 12, answer the following questions about saturated solutions that we talked about in our notes. Letter A, describe how a salt solution can hold salt in water. Remember the idea that those water molecules, when they're put together, there's little spaces in between. That's where the salt goes. It sits in between those. So it's in those little spaces in between the water molecules. Oh, hold on again. All right. Letter B for number 12. How can you make a saturated solution hold even more salt? The idea on this is raise the temperature and you can put more salt into it. That makes this spaces just a little bit bigger. And because they're just a little bit bigger, they'll hold a little bit more. So that'll make it so a saturated solution holds more. So the key thing there is raise that temperature. Letter C, what is a saturated solution? Well, saturated solution holds the maximum amount of solute. You got the most you can put in there. You put salt in every single little space in between those water molecules. Letter D, how can you make a saturated solution into a super saturated solution? Well, the key things on this, raise the temperature, add some more stuff, and then let it cool down really slowly. That's the key thing, is let it cool slowly. If you cool it too fast, then the particles will fall out and you won't have a super saturated solution. The other thing is you can't have any extra material down at the bottom. If you do, then the particles will fall out and crystallize on that. That actually takes this letter E. How do you make the solute in a supersaturated solution fall out? Excuse me, add some crystals. If you add some crystals, like in the making of rock candy that was on the video, they add some little crystals on the thing that they put inside of the supersaturated solution. That made it so as it sat there, the little crystals formed on it, and we ended up with a piece of rock candy. All right, number 13, you got to solve this one. All right, for this one, get rid of this. For this, utilize SP, System 1, System 2. And we're going to make this chart. So making this chart, now we go through this question. It says we got solubility of carbon dioxide in Pepsi is 0.57. So solubility, so 0.57 grams per liter. At a pressure of 204 kilopascals, so 204 kPa. And it says what would be the solubility if the pressure drops all the way down to 101. So the pressure is going to change to 101 kPa. We want to know what's that new solubility. Right? So we're going to utilize that equation, S1 over P1 equals S2 over P2. So here's my S1, there's P1, there's S2, there's P2. So now I substitute these things in. So I have 0.57, let's just make that look like a 5, over 204 equals X over 101. So I'm just transferring these over in there. Now solve this, and to solve it, you're going to cross multiply. So you get 204 times X equals 0.57 times 101. Then solve it by dividing both sides by 204. Now let's get that, I end up with X. And X ends up equaling this number, 0.282205. 882. I gotta look at it because it's really, really long. That's what the calculator pop up. Now what we gotta do is decide where in the world do I round this thing up? Ooh, this takes us back to that rule. We're multiplying and dividing, so it's all based on least number of significant figures. Well, this one's got 2 significant figures. This one's got 3. That one's got 3. So there's my key one. I can only have 2 significant figures. So my second significant figure is that. So this is going to round off to 0.28, and that happened to be grams per liter. All right. So in order to solve this one, make sure that you show all of this stuff so that I can give you points on it. If all you did is give me the answer down here, and I don't know where it came from, then I can't give you any points. All right, you've got to show me the work in order to get the points on this. All right, that concludes that review worksheet. So next is going to be the test. So good luck on the test. Make sure you submit it to me. We'll see ya.